Okay, so in this case, we've got effectively some sodium hydroxide reacts with arsenic, and what's produced is Na₃AsO₃, which is sodium orthoarsenite, and H2, so hydrogen gas basically. And we need to calculate the volume that the hydrogen gas produced is going to occupy at room temperature and pressure. Right, so one of the first things I'm going to try and do is work out, well, what is the number of moles of H2 actually produced, right? Because that would be a good initial goal, right? But to work that out, I would because all we've been given really is the mass of the sodium hydroxide that reacted. I would need to first work out, well, what's the amount of substance of sodium hydroxide that that reacts, right? And so the equation I'm going to use is the one that links the moles, mass, and molar mass, right? So the mass is equal to the well, I'll go straight to the number of moles is equal to the mass divided by molar mass mR, right? Okay, so in terms of working that out, our mass, we have that in the question, so we have our mass here. In terms of the molar mass, we can work that out from the periodic table, right? So in terms of the molar mass, so this is the molar mass of NaOH. So I'm just going to put this mR of NaOH, right, is equal to, so we've got sodium, hydrogen, oxygen involved here, right? So I've just got these here as well for convenience, but so that's going to be, for Na, it's going to be times 1, right? So it's going to just be 23. I'm not going to write the times 1 because, you know, you multiply by 1, you just get the same thing. So I'm just going to put 23 plus, for the oxygen, it's going to be 16, right? Relative atomic mass, so that's 16 plus for hydrogen, which is just going to be 1, right? And so if you work that out, that's going to give you what the molar mass of the NaOH is, which if you do that, is you're going to get 40. And that's going to be in grams per mole, right? So we've worked out the molar mass for the NaOH. So we know that actually, okay, for the mass, we've got 38.92, and for the molar mass, we know we've got 40, right? And so for the number of moles, we just do, and this is specifically for NaOH, right? So number of moles of NaOH is going to be equal to, let me just get rid of this in the meantime, it's going to be equal to 38.92 divided by 40, right? And yeah, so if you work that out, you should get let's see, you should get 0.973, okay, and that's going to be in moles, right? So we now have a value for the number of moles of NaOH, but remember, what we're aiming at is to work out the number of moles for the H2, right? Now, what do we notice from the question? Well, the question, if we look at the balance equation and the coefficient specifically, you can see the coefficient with the NaOH is 6, coefficient with the hydrogen is a 3. So when we can make a comparison in that sense, the number of moles of NaOH compared as a ratio to the number of moles of H2, right? For NaOH is going to be 6, and for H2 is going to be 3, right, as a ratio. And if we try and get both values, well, at least the value on the left, so the NaOH, if you try and get that value down to 1, right, so you're gonna have to divide it by 6, right? So divided by 6, and do the same to the other side, right? So divided by 6, we're going to have a we're going to have 1 on this side, and on this side we're going to have, well, 3 over 6. It's like 3 is half of 6, so we're just going to have 0.5. okay, but effectively, what does this tell us? Well, it tells us for every 1 mole of NaOH, we're going to get 0.5 moles of H2. In other words, the moles, or in this particular case of H2, is equal to 0.5 multiplied by the moles of NaOH, which, as we know, is actually, we've got the value of what this is, which is 0.973. So it's going to be 0.5 multiplied by 0.973, right? And if you do work that out, what are you going to get? Well, if you run that calculation, you should find that you get 0.4865 moles. Okay, and what we're also going to do in this context is we are going to take a look at well, we've got the moles, right? But we need to work out the volume. So we need to consider, well, what have we been asked to do specifically? We want to work out the volume at room temperature and pressure. Now, at room temperature and pressure, as we've been told here, 1 mole will occupy 24 decimeters cubed, and that's for any gas, basically. And so for this, we've got a given number of moles. We need to multiply it by 24 to get the volume that's going to occupy. So what we can write here is to say that the volume of H2 is going to be 24 multiplied by the number of moles of H2, which, as we can see here, is going to be 0.4865, right? And so if you work that out, you're going to get 11.676. Okay, that's going to be in decimeters cubed. Now, this needs to be rounded to 2 decimal places because of what the question asks for. It says, please give your answer to a maximum of 2 decimal places, right? So this needs to be rounded, and that's going to be equal to 11.68 decimeters cubed. Okay, so this is going to be our volume.